The foundations of nuclear science were laid in the late 19th century with the discovery of radioactivity. In 1896, Henri Becquerel discovered radioactivity, proving that atoms could release energy on their own. Marie and Pierre Curie expanded this research and showed that atomic energy was extremely powerful. By the 1930s, scientists discovered nuclear fission, the process of splitting an atom to release massive energy. In 1938, the confirmation of nuclear fission alerted American scientists to its potential for both electricity generation and nuclear weapons. In 1942, the U.S. government launched the Manhattan Project, the largest and most secret scientific program in history. The project was led by J. Robert Oppenheimer and involved thousands of scientists working at secret facilities across the United States. By 1945, the Manhattan Project successfully produced the world's first atomic bombs. The atomic bombings of Hiroshima and Nagasaki ended the war and revealed the immense destructive power and energy contained within atoms. After World War II, the United States faced a moral and political question about using nuclear energy for peaceful purposes instead of destruction. American leaders began exploring how nuclear power could benefit society beyond military use. In 1953, President Dwight D. Eisenhower delivered the Atoms for Peace speech at the United Nations. Eisenhower proposed using nuclear energy for electricity generation, medical treatments, and industrial development. In 1957, the Shippingport Atomic Power Station in Pennsylvania became the first commercial nuclear power plant in the United States. During the 1960s and early 1970s, nuclear power was widely seen as the energy source of the future in the United States. The U.S. government and private companies built dozens of nuclear reactors to provide cheap, reliable, and large-scale electricity. Rapid growth in electricity demand pushed America to search for powerful long-term energy solutions. Oil shortages and Cold War tensions made nuclear energy important for national energy independence and security. By the mid-1970s, nuclear power supplied a major share of U.S. electricity, making the United States the world's largest producer of nuclear energy. A partial reactor meltdown in Pennsylvania shocked the United States, showing the risks of nuclear power. Extensive news coverage heightened public anxiety, making Americans question nuclear safety. The catastrophic meltdown in the Soviet Union intensified global fear of nuclear energy and its potential dangers. Many planned nuclear plants in the U.S. were canceled or delayed due to safety concerns. Stricter safety regulations were implemented, but public trust in nuclear energy significantly declined. Existing U.S. nuclear plants continued operating safely despite the slowdown in new construction. By the 1990s, nuclear energy had become a reliable and stable backbone of the U.S. electricity grid. Advantages of nuclear power became evident. It provided consistent baseload electricity, emitted zero greenhouse gases, and operated with high efficiency. Concerns about climate change in the early 2000s renewed interest in nuclear energy as a clean and sustainable power source. Nuclear power was considered alongside renewable energy sources like solar and wind for reducing carbon emissions and meeting growing electricity demands. In 2011, the Fukushima nuclear disaster in Japan occurred after a massive earthquake and tsunami damaged reactors. The disaster caused global alarm and raised concerns about nuclear safety worldwide. Although U.S. nuclear plants were unaffected, safety inspections and regulations were strengthened. Some older American reactors were permanently shut down due to age, cost, or public opposition. Despite these concerns, nuclear energy continued to play an important role in U.S. electricity generation. The United States currently operates the largest fleet of nuclear reactors in the world, providing around 20% of the nation's electricity. Modern innovation focuses on small modular reactors, SMRs, that are safer, more flexible, and easier to deploy. Advanced safety systems have been implemented to prevent accidents and protect communities. Efforts are underway to reduce nuclear waste and manage it more efficiently. Nuclear power is promoted as a carbon-free energy source to combat climate change and enhance energy security. Nuclear energy continues to provide clean and reliable electricity to millions of homes across the United States. It plays a major role in reducing carbon emissions by producing power without releasing greenhouse gases. Nuclear power faces challenges such as high construction costs and public concerns about safety and waste. It competes with renewable energy sources like solar and wind, which are growing rapidly and becoming cheaper. Despite these challenges, many experts believe nuclear energy is essential for America's transition to a stable, low-carbon energy future. Nuclear power has played a major role in American history, from the discovery of atomic energy to its use in weapons and electricity generation. Nuclear power has raised serious moral and ethical questions because of its ability to cause both destruction and progress. The history of nuclear energy is a mix of fear and hope, shaped by accidents, war, innovation, and technological advancement. The United States has remained at the center of nuclear development for over a century, guiding how this powerful force is used for the future. 89393